Hey, everybody, welcome. It looks like it's 1 o'clock on the dot, so we're going to go ahead and get started. There will always be a couple stragglers because that's how it goes, jumping from meeting to meeting. My name's Stephanie. We'll get kicked off in a second. I am in our Houston office today. You can see one of our robots behind me. I have another one on the side of me. This is where we do a lot of our robot testing, fixes. We do training here, but we'll go ahead and get kicked off. Thanks for joining. So today we're focusing on tank inspections for power plants specifically, which is my area. I handle all of our power generation customers. So at the office here, I am also known as the Pink Power Ranger. I've been working with Square Robot for just under 2 years. And power was the one industry that I came in to really focus on. And we've gotten some great opportunities in terms of both customers and partnering with the Electric Power Research Institute last year, which I'll actually touch on a case study later in this session. But I'll let Praneeth introduce himself too. He is here for all the very technical questions I can't answer.
Hi, hi everyone, and this is Praneeth, and I'm like the subject matter expert for this uh, robotic inspections, and I got like 12 years of experience under NDT belt QA/QC, and around 6 to 7 years of experience in the plant inspections API side, and and yeah, I'm here with Square Robots like 5 months from last January. So I'll be here attending all your technical queries and yeah.
Great. Thanks, Praneeth. Great. So we'll get going. If you're unfamiliar, I see some people in the chat, some faces, or well, really names that I recognize. But if this is your first time joining in for one of our sessions and you're unfamiliar, we are the world leader in robotic tank inspection. To date, we've done over 200 tank inspections. And what I really like to point out is the savings to our customers, not just money, which we love the money savings, but also in terms of confined space entry. We don't want people in dirty, dangerous places, and as well as CO2 emissions. So we do work in fuel oil, which is one of the tanks or one type of tank that we typically see at power plants. So there's no release of emissions once we get into the tank. And although we started in, I would say, more of the midstream refinery space, you can see here power has become one of our biggest customers. The power industry definitely has a need for tank inspection. And let's just kick right off into that. Why do you have the need? One, it's regulated. So your API 650 tanks all fall under API 653 inspections. And you can see this is your typical power plant over here. This bottom right corner, I see power plants sometimes with just one tank, sometimes up to 5 to 8 tanks. But it's typically maybe one or a few fuel oil storage tanks. So you have a few of those and then a few water tanks. And that could be processed water for plant operations, demineralized water, condensate, fire water, all of the above. Lots of water and lots of fuel oil. Now, if you've never thought about tank inspections, probably because they're not frequent. So when they do come up, it becomes quite a headache for power plant operations. The API 653 tank inspections are usually between 10 to 20 years. You'll see those intervals. And then your NFPA firewater tanks sit around 5 years. So not something that you're doing every year, so not top of mind. And then the other, what I would say could be a nightmare for you if you do have one isolated fuel oil storage tank, you don't have anywhere to put the fuel. So it gets expensive. We want power plant operators, plant managers, maintenance managers focusing on the more important tasks, your turbines, the power generation aspects, using their outages to focus on that as opposed to your tank inspections. So we do these tank inspections all year round, not just in outage season. If you've done an out of service inspection for your tank before, then you know what it's like. You have your tank, it could last weeks, sometimes months. I usually hear at least 3 to 4 weeks from my power plant managers that I talk to. And what you're going to do if you're doing out of service is you vent the tank. So if it's fuel oil, that release of emission, drain, clean the tank, dispose of all the sediment and the sludge at the bottom. And then we have people crawling into confined spaces, which is never fun. And not what we want, because it can be dangerous. It's dirty. It's not really the safest job that's out there. So if you have a tank that's an candidate for a robotic inspection, that's what we'd like to move to instead. In that traditional out of service, you can see in the pictures, you will have guys that go in with their MFL, magnetic flux leakage, and then use a single element, a spot UT, to prove up any corrosion that they might be worried about, any corrosion spots that they find. And then often, because you're taking it out of service anyway, you're just going to do repairs whether or not they're needed. So they might not be needed. Maybe it's something that could have waited 5 to 10 years, but it's already out of service. So you think you're just adding time, money, resources to these out of service inspections. So what Square Robot does instead, the submersible approach. This video right here, it's our robot, like the one that we have behind me. And what we use this for is obviously your tank inspections. We'll get into some of the technical aspects in just a bit, but there are a few things I want to point out. One, we do the inspection with the tank full of product. We ask for a minimum of 15 feet, but I say the more, the better. So don't ever drain it down to 15. If your tank is full, keep it full. But we want to take that robotic inspection and replace the out of service. So in terms of data, we're giving by far higher quality and quantity data than any other robotic service that's on the market. So if you think old school crawlers, and higher quality and quantity compared to your out of service traditional. You're getting about 4 UT data points per millimeter. So if we're thinking like 100-foot diesel tank, that's 400 million UT data points that we're pulling. So that confidence level, your understanding of your tank asset, its integrity, is at the top. On top of it, if we think of that same 100-foot diesel tank, we're containing around 5 tons of emissions, CO2 equivalent emissions, and about 500 confined space entry hours. All of that leads to the ROI for your plant. So you don't have to take the tank offline. You don't have to drain it out. No alternative storage needs to be brought in, and you're not spending hundreds, sometimes thousands of project management hours just working on this out of service inspection. Let's keep going. How do we do this? I'd say we have a pretty simple approach. We are very self-contained, which is nice. Usually I go out, if it's a new client, go out for that first day, and the first day is always a spectacle. Everyone wants to know what's going on. They want to see how it works. But after that, they realize it's pretty simple. So we'll launch our robot from the roof, lifting with a crane or our internal lift system. Drop the robot, you can see right here on the left, through the roof manway. We do require 24-inch roof manway. Once it's in the tank, it's only connected with a small 1/4-inch fiber optic tether. It's not for power. There's never any power going from the robot while it's being launched. That is for communication only. The robot actually doesn't even turn on until it has 10 foot of hydrostatic head above it. So once it's in there, it will start its data acquisition. It starts with about 30 minutes of doing its initial navigation alignment, and then it autonomously maps the bottom. So engineering hates it when I say this, and they might be on this call, but think about a Roomba that's already learned the layout of your house. That's kind of what we're doing with this robot. We already have the tank drawings typically. We know what the internals look like. I like to say that it's semi-autonomous because every once in a while we'll run into things like a buildup of sediment or something that we don't expect. Sometimes the tank drawings, if it's an old, very old tank, they don't match what's actually inside the tank. So in that case, our robot operator can always take control, reset the nav, and then send it on its path. After that, we pull it out at the end of the day, decontaminate it, pull it down at the very end of your inspection, and then on the back end, we process all that data internally. So your API 653 report, or if it's just a visual report, will get delivered post that. And feel free to drop any questions in the chat while we're going. We will handle them at the end. But if your first thought when I talked about we launched from a crane was, oh, I don't have a site crane. We run into that all the time. we do have an internal lift system. You can see it right here, that video. It's like a little elevator lift, basically. Robot goes up to the top. It's just another asset for us to really keep our footprint small, help save you money. We send out a 3-man crew. You can see the van, the robot's in the van right here. And we really just want to be as safe and efficient as possible in your daily operation. So hopefully we get on site, you can worry about everything else that you have already going on. And we're just off to the side inspecting your tank and wrapping it up. We want to be the easy button for you. Okay, on to our technology. So what we provide as a whole is compliance. I know the API 653 I mentioned is regulated. It's something that you have to do in FPA fire water tanks, but even your process water tanks, depending on your internal company policy, regardless of what it is, we don't want any cracking. We don't want any corrosion in your tanks. You don't want to have to worry about a loss of water for your plant operations. So what we're providing with our robot is tank bottom thickness using our phased array UT. You can see the PAUT, that's what we call it. It's 256 elements. And I want to pause because I want us to think back to that out of service inspection where an out of service inspection would use a single element UT to prove up any suspected corrosion points. Let's take that single element, multiply it. We have 256. So high quantity, high quality data. With that, we're able to delineate between product and soil side corrosion. So where maybe the diesel is actually sitting, if there's corrosion on this side, all the way down to where your tank is on the bottom, maybe a cement foundation or the earth. We can tell the difference where that corrosion is. On top of that, if you're worried about coating, any coating failures, bubbling, blistering, we can measure through that. We've also done a fiberglass line tank actually for one of our power plants before. So if you have any concerns about that, it's something that we can handle. With that, we're going to give you internal visuals. So if you are worried about coating, anything like that, we do have 2 cameras on the robot. One that looks directly down at the phased array UT. So you can see right down here, this picture, that's that phased array UT. If you have a corrosion spot, it's nice, we can time stamp that up. Our accuracy with it is within 6 inches, so nice and tight. And that's actually one of our patented part of the robot is our navigation. So 2 cameras, we can show you your internals. But I would say the most unique thing that we do is our tank bottom settlement report, and it's settlement, how it's settling into the earth, not sediment, like not dirt, not sludge. And that's important because I like to think of a tank as a lung. So, you breathe, it's full, you have that little bit of flexion, you exhale, it goes in just a bit. We're taking these measurements while it's fully loaded. So tank is full of product. You understand if you have any concerns with tank shell buckling, if you have any low spots, any depressions, any water puddling, we're able to build out a real live heat map for you of what that looks like. So again, understanding your tank asset as a whole, understanding the root cause as opposed to just pulling it out of service every 10 years without knowledge of potentially what you did last time. And all of our crews go out with 3 people. So you will have an API 653 inspector like Praneeth here, who's there to also not only be there for the internals, but conduct any external UT readings needed for API 653 compliance. All right, into a little bit more of our tech, and then we'll jump into case studies. So that phased array UT, 12-inch rigid plane, you can see it right here. We're pulling A, B, and C scans. So that full approach, and what we do with this, we optimize the robot to get that most important part of your tank. You can see it right here. I'm going to play this again. It is pushing right up against the tank shell. See that? Within ½ an inch. And we're optimizing it to look at your critical zone. So that's where the shell meets the bottom, the most susceptible area for corrosion. That's that first optimization. When we look at your tank inspection, that's what we focus on. After that, we'll hit the rest of the internals, accessible coverage. And then you can see right here, this soil side corrosion. We'll go ahead, show any indications in your report, measure the wall loss, note if it's above your API threshold. And like I mentioned with our settlement report, If you do have concerns with water puddling, this one's interesting because you can really see it pretty clearly, a fuel oil tank, but look at all that water puddling that's sitting right underneath the PAUT. Just giving you, again, full confidence, high confidence of what your tank looks like. Now we'll hit a few case studies. I love these because it really shows you the impact, the investment, and then we'll open it up for any questions. But again, thanks for joining me today. Okay, this first one is great. I was on almost all of these inspections, which is always fun. I love to meet people in person, especially after sometimes you've been talking for weeks or months. It's great to put a face to a name. But this was a unique one in that they wanted to knock out all of their tanks at once. Makes total sense to me, but a lot of times these tank inspections are staggered. You can line them up all on one inspection interval. You hit it in one pass, and with that comes decreased costs for mobilization and discount for your inspection as a whole. So with this customer, they had 2 fuel oil tanks. You can see them on the left of the picture. They were, I believe, about 60 foot, needed API 653 inspections. But they said, while you're out here, we also need our water tanks done. So they have the 2 on the right. I believe it was a 34 and another 59-foot water tank. We knocked all 4 tanks out in 3 days, nice and quick. The first day was exactly what I said. I went out there, we got to walk down the robot, show all the components. They actually brought in nearby plant managers because you want to see the process. At the very end, a happy client, happy plant manager. We eliminated over 1,000 hours of confined space entry, contained 4 tons of emissions, saved them hundreds of thousands of dollars, which is a number I always love to hear. And they were actually jet fuel. The 2 jet fuel tanks got a 20-year inspection interval, so in great condition. And Paul, I see your question. We're going to touch on that at the end because that is a great question, one I hear a lot. The next case study this was an interesting one because this was at a power plant, and like most are, I was in the middle of nowhere. I've been to many where the only restaurant is about 30 minutes away. But it was in the middle of nowhere, and their problem was they had 1 single tank. It was isolated. They were going to have to bring in alternate storage to take it out of service. And they had what they called a sister tank. So it was another plant 10 miles down the road that had a tank that was similar size, similar application, fuel oil, and built around the same time. Now that tank needed extensive repairs when they pulled it out. So they assumed that this tank would as well. So they were going to do some proactive planning. They were going to drop us in so that they could find all their spots of corrosion that needed repair, have a repair plan so that when it came out in 2025, they had already budgeted out and found, or really budgeted out their materials, their people, had all the resources available to make that turnaround quick. Luckily for this customer, they dropped us in. I say dropped us in because the robot literally drops in. We inspected this tank in 3 days. We got about 78% of coverage, and we'll kind of touch on your question. So accessible coverage, and that's everywhere you don't have obstacles. So that includes your columns, your sump, anything that we don't want to get the robot tripped up on. 78% coverage. In terms of their plates, we hit 29 out of 31. And they were pleased to know their tank was in phenomenal condition. There were only 7 indications, and only one of those was above 25%. None of the 7 were above their API 653 threshold, which was great to hear for them. Their API interval, 20 plus years. They contained emissions. They kept people out of confined spaces. Everything that we want to do as a tool in your toolbox. There we go. And our last case study that I'm going to wrap up on here is the one that we did last year. It's actually published. You can find it online. Thank you, TVA and EPRI, the Electric Power Research Institute. They had a technology cohort program that we applied to and got selected to showcase new technology to the power industry. Now, we're not necessarily new. We've been in operation for 5 years now, but we were new at the time, newish to the power industry. We had focused previously midstream, downstream, tank terminals, refineries, those type of things. And we had only done a handful of inspections at power plants. So EPRI allowed us to join this program, which was great. We got paired up with Tennessee Valley Authority, worked with some awesome people there. And what we did in this particular case study, which we have another one as well that you can find online, but for this one, we inspected 3 of their fuel oil tanks in 3.5 days. Now, this inspection was really comparing the ROI and the past inspection, which was out of service. So if you see this top circle here, that's your tank bottom. What they had in their last out of service inspection were single point UT readings, and you can see right here around the outside in that critical zone, the inside, and the very center. So single point UT readings hitting the plates, but in terms of coverage and quality and quantity of data, we surpassed that. We dropped our robot in. You can see this bottom blue. We got 60 for all 3. There were identical tanks. We got about 60% coverage in each tank. They had a pretty large floating suction. And sometimes working with our customers, they can lift that out of the way. We can get even more coverage. A couple nozzles that we stayed away from. But when you think these passes, 256 elements on that phased array UT, we're getting about 100 million UT data points, as opposed to, I believe this is 28 to 40 UT data points up here. So high confidence, high coverage. We saved them $200,000. And when you think of TVA Power Company as a whole, their tank fleet for just their natural gas is 100 tanks. So when you look at it as a portfolio, making big impacts for companies, not to mention 6 tons of emissions, 500 plus confined space entry hours. All the tanks were in great condition. This was actually at a peaking plant. All 3 tanks got 20-year extensions. So it was a great inspection. I want to end with this because I do like to go out pretty often for these inspections. So I'll slap on my steel toe boots and hard hats and be there with you. But I got to sit with the plant manager after, and he told me, he was like, Stephanie, I don't like change at my plant, which I get. He's like, I don't like new things because it always creates unintended consequences, things that you don't foresee. But he said this was the first application that he's ever done where he could only see positives as the outcome. And that is a great thing to hear. And I know not every single tank is a fit for robotics. We just want to be an option for you. And when we can be, we want to create that positive impact, show you the positive benefits of what you can do, keeping people out of confined space, really releasing those project management hours to focus on the more important aspects of your power plant. So with that, we're going to run to questions. And Paul, I saw your question, so I'm going to hit that first. Anybody else, drop them in the chat. The amount of bottom that we can actually inspect. So we say we want to hit 100% of accessible tank bottom. I see you, Kyle. I'll answer it in just a second. So when we say accessible, we stay away from columns, sumps, nozzles, anything like that. And if you're really concerned, I mean, we've been in tanks that have had 49 columns, massive tanks at refineries, 49 columns, gotten that inspection completed. And if that is a concern, we can always take a look at your tank drawings ahead of time, give you an estimate of what we think we're going to get. But then you think back to the TVA inspection where it was out of service, and they got 28 to 40 data points. We're getting hundreds of millions of UT data points. So where we are getting that coverage, it's high quantity for sure, which is part of the reason we process our data in-house. And we have our own software. The robot is built and manufactured here by Square Robots, software built from the ground up. So accessible coverage, we average around 60 to 70%. That's typically what you see with columns, nozzles, sumps. But we've had some where they have one little nozzle on one side of the tank, a center columns, and that's it. And we're getting 90+%. It's very tank dependent. Inspections of a horizontal cylindrical tank. I saw that one, Kyle. So this one actually, the horizontal, I call them Coke can tanks because they're basically, they sit in a saddle. That is an STI inspection. So those are external UTs unless your plan states it needs to come out of service and have the inside done. Those are external UTs that we can pair up with a storage tank inspection because we do have API 653 inspectors in our crew. It's not something that we focus on because those aren't the applications for our robot. Our robot does need a 24-inch manway, and we need an above ground cylindrical storage tank. So if this was sat on the ground, this is what we're looking at as opposed to this. But if you do have that application, a horizontal tank that needs inspection, external UTs, and you have above ground storage tanks, that's definitely something we've paired up together for customers. All right, Eric, you're up next. Dye diesel, we work in it all the time. All the time. Red dye diesel is right up here with all the other products we've worked in. The one thing about red dye diesel, you asked about the video quality is not great. We were just in one where they had a level gauge floating and a chain attached to it. We were able to give videos and show that to the customer. But as a whole, in terms of your tank bottom, we love to have the video. We love to have the cameras. We don't actually need it. If you have concerns about the tank bottom, the phased array UT is going to show that. You have concerns about your coating, we can measure the coating. We can find if it has desponded or the laminates coming up, if they're bubbling, blistering. Red dye diesel is something we do all the time. We've been in tanks where the diesel looks pretty green. That is very common for us. So yes, we can do it. The video is not very pretty, but actually we had an inspection at a power plant where their inspector came and sat out in our van. That's where I have our mobile operations center. He sat with us and he's like, oh, I actually thought it would be worse. So you can see a little bit. It's just not the best. Not like a water tank or an alcohol tank or something that's really clear and clean. Okay. Well, you guys, it's 1:26. We said we go to 1:30. If you don't have any other questions that you want to drop into the chat, then I will leave you with this. My contact information. I handle all of our power industry customers. Oh, okay. Great question, Michael. Water in the tank affect the exam. So the inspection. So I'm going to start with a little joke. If it's a water tank, yes, it makes it possible. But let's think of a fuel oil tank. We run into a ton of tanks where special power plants, they can't do a water drawdown. So if there's any water sitting underneath that fuel oil, it's just kind of puddled at the bottom, as opposed to if you did a water drawdown, you could pull some of that out. It does affect the inspection because our phased array UT, we use the product that's in the tank as a conduit for it. So we need a 2-inch standoff. And when you have that mix, so it's not homogeneous, when you have a mix of fluid and water, it can attenuate our signal. And I know Praneeth has looked at all of our reports where he's seen that. Now, this doesn't mean we can't do the inspection. Most of the power plants that we go to can't do a water drawdown. It's just going to reduce the coverage. So you'll have some spots where the water puddling is a little higher. You have your water column a little higher, some that's lower. We'll still be able to do the inspection. It just reduces that coverage, and we'll be able to tell. So when you get that sometimes it's like the debrief of the tank and sometimes it's your report, we'll be able to note like this area had a lot of water sitting in it. That also plays into your settlement map as well. Cool. Praneeth, I don't know if you have any ending thoughts, but I want to thank everybody for their time. If you do have any inspections that are coming up this year or next, I'd love to put together a proposal for you. If you have any questions about what tanks are candidates, I'd love to look at your tank portfolio, suss out which ones would be a good fit for Square Robot. Praneeth, anything else? I know I talked the whole time, but that's what I do.
You covered everything. That's good.
Okay.
Yeah, only thing I want to point out is whenever there is a water puddle, it's just attenuates the signal more. And on the analysis part, you'll have a less back walls to properly read the signal. So it will be a little tough, but the coverage part will be a little tough. But yeah, apart from that, what you said is absolutely right.
Yep. Cool. Well, remember Square Robot, next time your tank inspections come up, we want to be a tool in the toolbox and hopefully make tank inspections less of a headache and more of a pleasure because you get to work with me and our great team. So everybody have a great Thursday and reach out to me if you have any needs, but we'll talk next time.